Well, my 3D printed / CNC machined impeller for the dust collector here is finally starting to give me some trouble. What's been happening is that little by little, that tiny set screw that goes in here, there's actually 2 set screws. They're loosening up just enough with either the heat of the shaft, which is just a little bit warm, and this is just PLA, or just the vibration. It's making its way forward, and you can see here that we're starting to get some burning, and it's rubbing on this front edge here as well. So it wants to try and come off, and it's binding up, stinking up my shop and making an awful lot of noise. Luckily, when it starts to make some noise, I can press the stop button right away and make sure that it doesn't damage anything. So unfortunately, we need to come up with another solution. So what I did was I went to Princess Auto and I picked up this steel hub, and what I'm going to do is try and combine 3D printed hub and a steel hub into one, getting the best of both worlds, the mountability, the ability to create this complex part so that I can mount it, and also having the really precise fit and the ability to have the set screws going into steel so we don't have something loosening up over time. I have made some little tweaks to the dust collector since the last video, so pretty obvious one. I've added the power meter in here and also the switch. So now I can monitor the amount of current that's being used compared to the rating on the motor, which is 13.2. And I usually hover somewhere around 10.8 amps. So I know I have a little bit of wiggle room. There is an initial spike during the startup sequence. I've also added 4 casters. Each of them swivels all the way around. So I have only a little bit of clearance here to the floor, but that works just fine. So it's pretty easy to move around. And the reason that that is important is because this dust collector is so tall, I just don't have that much clearance to the ceiling. I've also made an adjustment up there to the tensioning system, and that way I removed the piece that stuck up above and I brought it down to the same level as those grommets that you can see there. I've also added a gasket all the way around here. You can still see that there's a tiny little leak there. So I'm gonna have to work on that area a little bit more too, but aside from that, it seems to be working pretty well. Unfortunately, none of my 3D printers are large enough to print this as one single piece, and it would be pretty difficult to do that anyway because of these large horizontal sections. So we're gonna go ahead and do it the same way I did it last time, combining MDF and 3D prints into one. Instead of 9 blades that I had before, now that I know how much amperage I'm using, I can actually up that. So I've got 10 blades, and I've also flattened them out to hopefully prevent a little bit of that sawdust buildup. They're definitely more like an aerofoil. And if you can see, the leading edge here is also quite a bit more curved. So instead, this might get dinged up over time, but it's definitely not gonna break off. And I was originally thinking that I would 3D print a piece and that way I could mount it to the MDF, but I was able to find a piece of steel that I can weld onto this. I just need to machine the center of it out. The original overall was also only 92 millimeters thick. After taking some measurements of the housing itself, you can see that I'm using up quite a bit more space. So this one overall is 105 millimeters thick. That means we have a lot more blade surface area. So the first thing we need to do is get these 10 fins or 10 blades printed out. I'm gonna be printing them from ABS this time. I'm just gonna be using standard Bamboo Lab ABS. Because I'm gonna be using super glue and epoxy, it should bond fairly well to the ABS. Over at the lathe, I have the gear already mounted. And unfortunately, the one that was on sale had the wrong size of hole, so I'm gonna need to bore that out. You can see here, I have the boring bar already mounted in here. Just need to remove a little bit of material. And I was able to get a nice press fit between the 2 pieces, but I am still going to weld this together. I also need to mark the holes and drill and tap those holes too. The original idea behind these cutouts that were in here was to provide a little bit of visibility, but also reduce the weight. Now, I'm not going to do that this time. You guys pointed out that it does affect the efficiency of the system. So what I'm going to do instead, at least for now, is take what was an MDF front panel with a small window to view inside, and I'm going to replace it with this piece of acrylic. This is a little bit on the thin side, but it is going to be bolted all the way around, and I am going to be mounting this piece to it, so it should provide a little bit of rigidity. Long term, I actually want to add some LED lights inside there. I want to have the whole thing, or as much as possible of it, to be clear, to be able to see what is happening with the sawdust with the different impeller designs that we try out. Normally to cut acrylic, I would use a laser. Unfortunately, this being clear acrylic, I don't have the right wavelength of light to cut this, and also it's just a little bit too large to fit on my laser. So instead, we're going to be using the CNC machine, and I'm going to be using this router bit, which is an 1/8 of an inch single fluted down spiral. And the benefit of the down spiral is that it should try and force the material a little bit down towards the spoil board and prevent it from lifting off and potentially ruining the part. So I'm going to go ahead, get this loaded in. We'll do a dry run as well, just to make sure we know exactly what we're going to get and where the part's going to be positioned. It's not super easy to see, but it just barely cut into the spoil board, which is just perfect. And I can take the clear acrylic, and it is just the right size. I'm really lucky. And with clear acrylic, you can actually see the cut directly below it. Now, normally to secure this to the table, I would use something like double-sided tape, but I don't have any double-sided tape that is the right stuff at the moment. I only have the thick foam tape. So I'm not going to use that. I'm going to use a glue gun instead and see how that works. Now, I've never tried using glue gun before to adhere something to my CNC machine. Seems like it's on there pretty good. If I were using an upcut spiral, I would be a little bit concerned because it would want to bring this material up. But instead, with a downcut spiral, it's going to be forcing the material down towards the table. It turned out pretty good. I would say the holes weren't quite as nice as the inside and outside cuts. So let's see if we can actually pop this thing off now. Oh yeah. Looks like I'm removing a little bit of the MDF on there. That's all right. Not too bad for a first try. So this was pretty old and pretty dusty. What I did before I used the glue gun was just made sure that the surfaces were completely clean. That way I could get the best bond with the glue gun possible. And for cutting MDF, I have an 1/8 of an inch compression cutter loaded in. They do make plastic nail guns and plastic nails specifically for this task. Maybe that's something I can try down the road. And this is where you could see, it really would be ideal if we had some sort of camera system where you could place your material, even without nailing it, just place it where you want to do the machining. And you can even mark with a pencil where you want to nail. And it would project the toolpath on top of here, and you can make sure that you've got exactly what you want before you go ahead and try and machine it. It would save a ton of time, just like what they do with the laser. That's why it's important still to have tabbing on small parts like this. Whoop. And now we can test fit our Frankenstein hub. And that is a perfect fit. I'm very happy with that. And to test fit the 3D prints, this side turned out really nice. The ABS is quite smooth and it's pretty slick too. Unfortunately, this side, not so much. The seam should be on this back edge, so it looks to me like it's just related to not drying the filament enough. This has been sitting around the shop for quite a while, and I just took a risk thinking that it was okay being in a bag, but unfortunately it doesn't look like that was the case. Now that's quite a tight fit. It's a little bit too tight for my liking. I do want a little bit of a space for some glue. So I'm going to go ahead and adjust this, but I'm only going to export the toolpath for the housings rather than the entire thing. So back panel housings, I'm going to load that, make sure we've got just the housings, which we do. That is perfect. So I am drying this ABS right now. You can probably hear it in the background. I want to give these another try, but I don't know if I'll have enough time. So I do have this Prusament ASA. I'm going to go ahead and reprint all of these. All right, let's see how the first batch did. I wanted to print only 5 at a time. I need a total of 10. And so far they look pretty darn good. Whoa, that's hot. This is the new build plate from Bichu, the Cryo Grip. Definitely comes in handy because, yeah, you cannot grip this if it just stops printing from anything but the hexagon front here. So that does work pretty well. The reason I wanted to do this was I want to get started on the next ones right away, and I want to keep the heat in the printer. And there is no glue on this. Let's see if it pops off. Still pretty good bond. Wow. So there's the ABS that I did not bother to dry, and I will print that one again. And then here is the ASA right out of the package. Normally a print like this would try and lift and they stayed completely stuck to the build plate with no adhesive. Now I did add the mouse ears, but aside from that, pretty good result. Bichu is also very nice to me and they sent me this. I assume it's something that they'll be selling, the Panda Edge, and they even engraved it here. Need it, make it. So this is a scraper. It's got the magnets on the back. These are pretty strong neodymium magnets. So let's try this one out. Ooh, yeah. Works like a charm. So I only printed 5. I could have easily printed 10, but I did want to make sure that it was going to turn out before I wasted that much filament, and they turned out great. So with the printer still hot, I can get the other 5 going. And this time it has cooled completely. Look at this one, did come off on its own. These look good. And I have this 2mm thick cork. I thought it'd be a great opportunity to actually use it to make some gaskets for around the front of our dust collector. And I'm going to turn on the fume extractor, but I'm also not too fond of any of this air going back into my workshop, so I'm going to open the garage door as well. Because I manually marked and drilled these out in the hub, I figured it was a good idea to do the same on the MDF rather than trying to do it at the CNC machine and risking everything not lining up completely. Now, the last time that I did this, I used super glue first, and the issue I ran into with the super glue was that it absorbed so much into the MDF and it ended up costing me quite a bit of money just in super glue. So instead, I'm just going to use this 5-minute epoxy instead, and it should give me a lot more open time, which means that when I go to put the top piece on, that I still have a little bit of flexibility in the movement and that I can align everything just right. With the super glue, it tends to be pretty hard and pretty brittle right away. And let's see how that ABS did when I dried it. Oh, quite a lot better. Look at that. Yep, that turned out pretty nice. So definitely was an issue with moisture in that filament. After I made the previous video, some of you asked me why I didn't use the original impeller. And there are two good reasons for that. One is that the bore size for the original is much too large. It was for a 3 horsepower motor, and I think this was inch or inch and an eighth, I can't recall exactly. And the other more obvious issue is that when they tried to remove it, looks like they used a claw hammer or a framing hammer. This is all broken. It's all fractured in here. Not every single one, but there is a big crack that comes along here, right along here, and then actually through the casting right to this point. So this is not usable, but it is definitely a lot of good aluminum that I can melt down and make something else out of. You can see, even though I vacuumed it, there's still quite a bit of sawdust buildup in here. So this is one of the reasons why in this configuration with the impeller, before the dust collection or before the filtration, that you're gonna have trouble with this type of design. So I think this is gonna work really well, and I'm pretty happy with how it turned out. It definitely looks a lot more professional, minus the gear teeth on the outside there, but you know, it's got a little bit of personality to it. This one here was pretty sloppy. I had a lot of excess epoxy on here. So if I slip this on here, we should be able to see a pretty big difference between the two. So it spins in this direction, and these are backward curved blades. They're not aerofoil shaped blades, they're just curved. And there are only 9 of them, but you can see how far back from the front of the housing there is. So there's quite a bit of space for air to come back. Not to mention that the blades are not as deep as they could be. So I think that's another potential loss from the original design. There we go. So with the new one, you can see how much closer it is to the front of the housing. So it's back about 1 millimeter, 2 millimeters, around 1/16 of an inch from the front of the housing. So that's just perfect. I don't hear any rubbing at all. So I'm gonna get this bolted in place. Now I was thinking about using Loctite, but because I want to take this off and put it back on, test some different designs, I think I'm going to avoid using Loctite for now. But overall, pretty happy with how that looks and how that functions. Already just spinning it like this, I can feel a little bit of air trying to come out here. So you can see there's not a lot of benefit to having this clear, but eventually I'd like to try and experiment with some different materials, and maybe I can get some materials that are clear as well. We can really see what's going on. That's not too bad. So it is time to plug it in finally. We'll turn this thing on and we're going to monitor the current during the initial startup and also for continuous use as well. Compare it to what we had before. I also have a bit of sawdust in here. We should be able to see some motion, some swirling motion. So before we were at 13.8 for the initial startup, which lasted only for a second or two. And then we jumped down to 10.8 for the continuous use for the current. So let's see where we're at now. So I was running about 10.2, 10.3 amps continuous, and that's actually really good. It's better than what I was doing before. Now the interesting thing is that I'm taking up more space in the housing in the width, but the blade design is quite a bit different than before. I had backward curve before, and now I have backward inclined blades, and hopefully that does help a little bit with the sawdust buildup. Overall, I'm pretty happy with that. The initial startup is a little bit higher. Let's go ahead and get the planer hooked up and we'll get some dust into the dust collector and see how it does. Eventually I will be reprinting this so that this will be a thread on just like the MagMate connection that I have and I've been using. And it's been working great. It's definitely plenty strong to stay on there on its own. So we can see the back side here is pretty clean, but if we flip it over, you can see quite a bit of dust buildup there. So that could become a problem, I guess, if the dust gets thick enough and gets out of balance. So maybe straight blades or slightly more straight blades than what I have here is a good idea. But overall, still fairly happy with the result. Ended up being a lot less current than I was expecting, so there's definitely a bit of room for improvement. All right, let's turn this on and we'll try and be safe about this. So you can really see what's happening without the front cover on here. It is trying to push quite a bit of air out. So there is a fair amount of resistance in this system to the air just moving up the duct. We have the filters up top there as well. So unfortunately, the original hub did not work out. That tiny little section of threads was the failure point, but actually it lasted fairly long. It lasted several months of quite a bit of use. So I'm pretty happy with the results of that, but I'm probably gonna do a straight bladed design and try and dial it in as close to 12, 13 amps as I can for continuous. So if you have some ideas for different designs and you wanna see them tested, let me know down there in the comments below. We'll have a look at the air speed, the volume of air being moved, and also the current. For now, I'm gonna keep on using the one that's installed. I hope you enjoyed the video. Thanks to all my patrons for helping to support this channel and making these videos possible, and thank you for watching. Take care, and we will see you on the next one.